Okay, in this video we're going to talk about everything in C, or many things in C anyway. So we're going to talk about reserved words, operators, etc. We'll see, this is going to be a long video. A reference that you could look at that's at a pretty basic level is this one. It's just kind of good to read through. It has basically very short little pieces of code and examples for all the different things that are parts of the C language. I have notes in this ISU core information. I'll just switch over here. So I have some notes here on what we're supposed to know about C programming. We'll start with the operators and punctuation, and this is a complete list that I can remember. We'll skip past functions we're supposed to know and look at all the different reserved words and what they do. So all of this is on your list of things that you should be reading about that I can use when I need to in programs. And to give you something concrete to do, we'll have a quiz coming up on all the operators and keywords, and the things that you should be able to do is, given a weird expression, figure out what it evaluates to, or some sort of short answer basic question about what's the operator to do XOR or something. Alright, so let's start with the operators and punctuation. I'll skip past the basic arithmetic, plus, minus, divide, times, percent. You know that these two here are, if you do integers, then the divide does integer division, that means rounding down, and with integers the percent does remainder. Okay, so I'll skip past those and go to bit ops. And I'll put this into just a file called lots of C. And what we'll do here is I'll type examples, compile and run, and just add to it. We'll have a split window so we can always see the current code that we're working on. Alright, so Boolean and, if I do, bitwise and, so if I do printf percent x, okay, so what if I do, this is hexadecimal here, so what if I do 0xff with 0x88, and. So what the and does is it take each bit of the first one and it with each bit of the second one, and I'm not going to review that because that's 151 and 201 material. Okay, so if you and anything with f's, you get whatever you got back. So what if we do an or? If we or anything with f's, then we'll get the f's. So that's the last one there. What if I do it like this with or? So what you could do here is, as I type these in before I run it, maybe you try to think about what would it output. There's XOR. So let's take this one and change it to XOR. So what XOR is looking for is it takes 2 bits and wants precisely one of them to be 1. Okay, so the areas where there's both a 1 in both places, that'll be a 0, if there's a 1 in only one of the places, which means the F, that comes out. Alright, so those are those bit operations. Now let's see, there's only two more, is the shifting. So the two less thans is shift left by 2, so this puts 2 zeros on the right hand part of that. That's also the same as, let's just say we take some number 23 and shift it by 2. That's the same as multiplying by 2 to the 4th, 2 to the second power. If you shift by 1, that's multiplying by 2. If you shift by 2, it's multiplying by 4. If you shift by 3, it's multiplying by 8, because we're doing that in binary. And each 0 that you add is multiplying by 2. We could do the same thing with a right shift. That would be like dividing by 4, or moving these bits over. Okay, so those are bit operations. I should be able to give you some weird expression with bit operations and you can evaluate it. Logical operations and an or, so everything is an integer in C. If I do 1 and 0, what is that going to be? That's a 0, so that's the logical and. What if I do 1 and 1? That's a 1. What if I do 15 and 10? 15 and 10 are not true-false values, but in C, anything that is not 0 is considered to be true. So this is like true and true. The whole thing should be true. And then the value that C gives for the true expression is 1. Okay. We'll go with, why don't we move the memory down below a couple. Alright, so for assignment, anything that we can do with two, it's a binary operator. Binary operator means there's left and right. Anything that we can do with left and right, we could turn it into an assignment statement. So we can have int x equals 3, x shift left equals 2. So that means that's really the same as saying x equals x shift left by 2. What should that be? Shifting left by 2 is like multiplying by 4, so it should be a 12 there on the end. There it is. Alright, and we could do any of these other binary operators. If we did XOR, then it would be like doing X, XOR, and then whatever we have on the right hand side. You'll most often see the plus equal, time equal, minus equal, but any of the binary operators you can do. Okay, comparison. So what is the value of something like 3 is less than 4? Okay, is 3 less than 4? It is. If you use that in an if statement or while loop, that would evaluate to true. Here, if we print the integer value, it is 1 for true. So what if I do is 3 greater than 4? It is not. Why don't we leave both of those there? And then we could do the other variations as well. Is 3 not equal to 4? It should be. Is 3 equal to 4? It should not be. And there we saw a 1 for the not equal and a 0 for the equal. Now, what if we make a mistake and do this? Let's do this. Okay, so what was the value of x? X was 12 up here. So is x equal to 4? It is not, so you might expect to see a 0 there. But the last thing we see is a 4, because this equal is not for checking equality, it is for assigning a value. What happens here is we put the value 4 into x, and then the equal expression has the value that was just saved into x. So this whole expression has the value 4. It doesn't have anything to do with true and false because it's an assignment. This is the checking whether something is equal to each other. All right, and we also have less or equal to, greater than or equal to. Now we get into, I'll say, let's do some things that I can just say here. So the parentheses are used for grouping, defining a function, calling a function. So here we have calling printf, we have the parenthesis with the parameters to the printf function in between parentheses. We can also do parenthesis for order of operations. So we could say 3 plus 2 times 4 or something like that. Order of operations says we do the times first, meaning we should see an 11 there. There's an 11. If we put parenthesis, then we'll do that part first, and we should see 20. There's the 20. Okay, and we might have to use the parenthesis other times as well, not just for arithmetic. If we have an expression like let's say we have int x equals 6, int star y equals address of x. Why don't we do this? We give 5 of these, and then we can see some other things. So here we have x as an array of integers. There are 5 of them. If I do int star y equals x, then this is a pointer. It has the address of the first spot in this array. That takes off a few other things on our list. The curly braces are used for compound statements. The body of a function is a compound statement. Also, the body of an if, for, or while is a compound statement. So the curly braces are used for that. We also have it used for an initializer list, like this. All right, so what do we see if we do printf y? We got an error. Okay, we have a variable named x already, so we'll call this capital X, which is different than lowercase x. All right, so now this last thing we're seeing here is just some kind of integer. The reason is because if you just take y there, it is a pointer, so you get the address. So the address where this array is. So which byte in memory is it? If we run it multiple times, we may get different values because it shows up in different parts of memory when we run the program different times. Okay, so this star here, it can be used for arithmetic. This is now used for declaring a pointer. Star is dereference, star is declare a pointer. All right, if we put star here, So when we're declaring a variable, star means it's going to be a pointer. When we're using the variable, star is dereference. So instead of printing the location, we want to print the value that's in that location, which should be 6. So there's 6. Okay. If we had, instead of capital X here, we can have address of little x, which was a variable. So here we see the ampersand being used for getting the address of a variable. And the little x variable must have been 4 the last time we did something with it. I'll leave it like this. We could have done ampersand x there. That's our list of things involving memory. And in terms of the order of operations, we might have something like star y plus plus. Okay, now there's two things that need to happen here. Y is a pointer, so are we increasing the pointer? That would mean that the location we're pointing to, instead of being the 6, it would be the 7. Or, so is that the first thing we do? We increase the pointer, or are we taking the value with the star? You have to go look up which is higher precedence, the star or the plus plus. If you know what you want to do, you don't want to look up the rules, then you can put your parenthesis in there. So this would take the value at location y, which should be the 6, and then adds 1. Now if I printf x bracket 0, should be 7. There's a 7. Alright, so we have dealing with memory, ampersand and star, we have the curly braces, we have the square brackets here for declaring an array and for accessing a particular element inside of the array. In terms of strings, we have single quotes for a character. So we have char C equals H, char S10 equals hello. So we have a single quotes for doing a single character, double quotes for doing multiple characters, a string. So there we see the single character and the string. Now there are a few characters that we can't really put into a string, so we have to escape them. One is a new line. So if I want the character to be really a enter character, then some programming languages would let you do this. Let's see. There was an error. Okay. C doesn't let you do that. Instead, you're supposed to put this /n. Okay. And it has to be going the correct direction there. So when we print, instead of printing the H, we have the /n. Also, if we wanted to do the single quote character itself, it wouldn't work to do it like this, because the first two quotes there would look like you have your character and then it's confused. So we have a slash for that as well. Similarly, inside of the string constant, if we want a double quote, there it is. If we want maybe we want a new line here, that would go there. There's also a /t for tab. All right. Those are things having to do with strings. Slash slash is for single line comment. We have slash star star slash for multi-line comments. Pound for preprocessor, which we've seen mostly with the pound include, but we can also do pound define true is 1. And then down here, we can use that. It's kind of like a variable, but it's handled. The preprocessor does things before the program is compiled. It doesn't take any memory. It'll just put the value 1 into my code here, actually before it's compiled. There's other things we could do with the preprocessor. Those all start with pound. The question mark operator. So we could do something like var y. Do we have a var y? We do. Z equals. Now we can give an expression. 3 is less than 4. And then, so not var, we want to maybe make this a string here. So 3 is less than 4, it is less than, colon, greater than. So this is just the order that you would do an if test. But now I could do z gets a value without having to do an if test. This is just a shortcut for the if test. So I could actually even put this whole expression right here in the printf statement. So instead of doing if 3 is less than 4, then less than, otherwise greater than, this is just a shortcut for that. All right, we have semicolons for the end of a statement. Colon we've seen with a go-to label. So, for example, if I have a label here, skip, and I could have go-to skip. So that would skip past this right here. So we shouldn't see, and I don't see that less than anymore. Comma, used for separating things. So we see that in the program here, separating parameters, calling a function. Also separating parameters in defining a function, separating items in an initializer list. So all comma. Dot is for accessing structure members, which we'll have to check the time. We can probably do that. All right, so the stuff that we have not done is having to do with structures. We'll go ahead and do structures here, which is going to go into our starting to look at some of our keywords, but we need to talk about structures to be able to talk about these punctuation items. Okay, so let's see if we can do this. Struct complex, and I'll do double real, double imaginary. Okay, so what this does here is it declares a new type that is called struct complex. So I can do struct complex, say point.real equals 1.1, 1.2, point.imaginary equals 2.3, or something like that. Printf, %lf, %lf, point.real, point.imaginary. Okay, so it wants me to have something here. All right, now we see that 1.2, 2.3. So a structure is just keeping multiple variables under one data type. So this is called a compound data type that we have. This struct complex is a data type that itself is made out of multiple things. And we saw the dot here for getting an item out of the structure. We can have pointers, struct complex star p, and now if I say p, so p equals the address of point, and then I could do star p dot real equals something else. So if I put that up here, let's see, we'll put that before the print statement. So we should see now let's see, we should see a different value when we print. So there's the different value when we print. So this here of star p, so go to that address, take the real part. That happens a lot. So there's a shorthand that is slightly less typing and looks a little bit nicer, which is p arrow. We pronounce this arrow, the dash greater than. So that goes to the address where this pointer points and takes the real member out of there. Okay, that is a struct. Let's see how we are on the punctuation. We have the arrow. Curly braces here potentially can be used inside of a structure. So we have those curly braces. There was another one where we had int flag 1, 1, int flag 2, colon 1. So what this colon does here is this is a bit field, allocate 1 bit. So if I say point dot flag 1 equals 1, point dot flag 1 equals, let's see, flag 2 equals 1, printf. Okay, so we should actually call this an unsigned int. It's only 1 bit. It doesn't make sense to have it be a signed int. So there it is. All right. Now, what the compiler should do is it should store both of these together. And so instead of, it's not going to take up however much space an unsigned int takes up, it's going to take up 1 bit. So if we have something that's really just a bit and we have a lot of those, maybe we have an array of these, this lets us specify how many bits we really need. And then our program should follow that. What's going to happen if I do something like this? I still see a 1 there for my flag 1. Now I see a 0 because it's really taking the binary representation of this. But is that going to mess up the rest of my structure? So that could be an issue. We should just use it like that. All right, so we think that's pretty much all of the operators and punctuation that we could think of. And that's a pretty good place to stop. So we'll stop there, and this is operators and punctuation.